We're to the point now where we've talked about the multiple ways in which we can try to solve quadratic equations. So the next step is to kind of take all that information and move a little bit forward and talk about how you would solve something that happens to be an inequality. Now, the initial process is pretty much the same as factoring. We're going to go ahead and factor, but when we factor and we get solutions or roots or something like that, they're not going to be used in the same way that they were used before. Or basically, you're not just done when you get to that point in time. Right? You're going to use those roots or solutions to help figure out basically what intervals are going to be solutions to the inequality. And you have to think back to when we talked about just linear inequalities. When we had something like this, all right, where we graphed a line. The line itself could be dotted or solid depending on what this sign was. And then we essentially shaded above or below the line, which would represent all the XY points that would make this particular inequality true. All right. Now, it's not really a whole lot different when we have quadratic inequalities. All right. The only thing that's going to change a little bit is instead of having a line, you're going to have a parabola that you can see down in the bottom right hand corner. So if we are just asked to graph these and determine where the solution points lie, it's very similar to when we had linear inequalities. All right. So we already know how to graph quadratic equations. The only thing that differs with quadratic inequalities, like I said, is your line going to be solid or is it going to be dotted? All right. If you have a less than sign or a greater than sign, there's no equal to involved with it, you're going to make your parabola dotted. If you have the equal to aspect with those, you're going to make your parabola solid. All right, so you're going to go about graphing these the same way we did before. All right, find your vertex. Use your y-intercept. All right, then find another point on either side of the axis of symmetry and go ahead and mirror that point over so you have at least 2 points on each side along with the vertex. Okay, then it comes down to we got to do a little bit of shading, because remember, typically with an equation, the points that satisfy that equation are points that actually lie on the line, okay, or lie directly on the parabola. In this case, right, we are looking for, yes, in some cases, the points that happen to be on the parabola are solutions. For example, if you have your equal to aspect to your inequality sign. However, there are also a number of other solutions that will also satisfy that inequality. And when you have just the less than or the greater thans up here with no equal to, then the points that are actually on the graph of the parabola are not solutions, but we have to go ahead and figure out what other areas are going to give us solutions that make that true. So if you look down here in the bottom right hand corner, all right, the graph that is shown for you is an example of something that would be y is less than or equal to that type of parabola. You have the parabola drawn. You notice that it has a solid line. All right, meaning that if you have a point that actually is on the parabola, it would be a solution. All right, now at the same time, you'll also notice that because it was less than or equal to, we shaded everything outside of the parabola. All right, what that indicates to us is if we were to pick a point from anywhere in that shaded region and fill it into our original inequality, it would make the inequality true. On the other hand, if we were to take something that happens to be in this unshaded region and fill it in, it would make the inequality false. Now, remember back again to when we did linear inequalities, usually our test point that we picked was always 0, 0. All right, in this case, 0, 0 happens to fall in the unshaded region. So what would happen if you fill 0, 0 in is that it would not work, or it would not make the inequality true. All right, which in this case is okay, because if we're using it as our test point and it's in the unshaded region, it shouldn't make it work. Okay, so just something to think about. Again, 0, 0 is probably always your best bet to fill in to check. You just need to make sure that you understand if 0, 0 comes from the unshaded region, it shouldn't make your inequality work. If it does happen to be in the shaded region, right, it will make your inequality work. All right, now again, you could take any points you wanted to and fill them in to use them to test. We just typically stick with 0, 0 because it's the easiest to make this work. All right, now you're going to have a couple examples as you go through your homework where you have to graph and you have to shade and do all that stuff. Now, I'm going to kind of abbreviate the whole graphing process here a little bit, simply because the inequality I have up here probably isn't the easiest in the world to graph. So that's why I already have the graph up here for you. All right, and just remember, going back to everything that we did before, graphing these would be the very same that we did when they were equations. You have to find your vertex, all right, use your y-intercept, then find another point, so on and so forth. Now you can see in this one, the vertex is going to be down here, and you'll also notice that it's kind of out in the middle of nowhere, and it's not really right on whole numbers, and that would probably be a result of this number in here being odd, meaning you're going to get a fraction when you do your negative b over 2a thing, and then as a result you're going to have to go ahead and fill in a fraction, and the ones on your assignment are going to be a little bit easier than that. All right, now you can also see our y-intercept is supposed to be 10, and you'll notice excuse me, that 10 happens to be where we cross the y-axis. So you would get to the point where you graph this. You would also notice that the line that we have on our parabola is solid because we have this equal to aspect over here. All right, now it says greater than or equal to. Well, in the example I showed you before, if we shaded outside of the parabola, if it was less than, that means in this case we're going to shade inside the parabola. All right, now again, what this means, and this would continue up forever if those lines were to keep going, all right, but what this means is our solution points, or the points that make this inequality true, come from the shaded area. Now you will also notice that 0, 0 is outside the shaded area again. So if I fill that in, 0 for y and 0 for x, all right, this inequality should not be true, and that looks to be the case here. All right, because all of this is going to be 0. So 0 is greater than or equal to 10. Well, that doesn't make any sense. But in this case, it shouldn't make any sense because that 0, 0 point comes from outside the shaded region. Okay, now that's what you're going to start with. All right, just graphing and trying to determine one way or the other whether or not well, I shouldn't say whether or not, where solutions that would satisfy the inequality are going to come from. All right, now the next thing we're going to do is, instead of having y is less than or equal to something that is quadratic, we're actually going to fill numbers in place of that y. Now eventually we're going to set these equal to 0, but the entire process is a little bit different, because now we're not necessarily looking for all the different values, x, y values that are going to make the inequality true. With these, we're kind of given a y value to begin with, so we have to figure out which x value is going to give us values that are going to be less than or greater than that particular value we start with. Okay, now this is what I talked about from the beginning. Essentially, we're going to factor these and solve them just like we did before as far as roots are concerned. But those roots aren't going to be their answers. They're going to be what helps us get to our answer. All right, now you'll notice here it talks about something called critical values. Essentially, when you factor and you set those factors equal to 0 and solve, in the past we called them roots or zeros. In this case, because we're talking inequalities, we're going to refer to them as critical values. All right, and the critical values are going to help us figure out the intervals for x's that are going to make our inequalities true. All right, so we're going to start with something that looks like this. And if you want to think about it this way, basically this -3 is in place of the y. Now, what this means for us to start with is, if we were to graph this parabola, when we solve for x, what we'd be looking for initially would be all the values of x that are going to make this side, the left side, less than or equal to -3. So if you think about a graph, and I'll draw it up here in the top, okay, -3, all right, would be a line that's down here somewhere, just generally speaking. All right, if I have a parabola, in this case that opens up, all right, because we're positive out here. All right, if I have something that's graphed, say for instance like this, all right, what we're looking for in this case is the x values, basically in general from here to here, where my graph is below -3 or less than or equal to -3. So my solution range would be whatever x values these are up here. Okay, well, instead of thinking about it in terms of -3, we're going to do similar to what we did with every quadratic equation that we solve. All right, we're going to set it equal to 0 or get 0 on one side. So in this case, I am going to add the 3 over, so I'm actually going to get plus 21 is less than or equal to 0. Now when we think about this, instead of looking for the points of the graph that are less than that -3 line, we're going to be looking for the x values that make my graph less than or equal to 0 or less than or equal to the x-axis. So this becomes a little bit easier. Now most of these you should be able to factor. All right, so x and x minus minus, I'm going to go 7 and 3. All right, now I realize there's an inequality sign here. We'll come back to that in a minute. Because this isn't really solving for the inequality, we're going to go ahead and put an equal sign in there quick. And we're just going to basically set each of these equal to 0. Sorry, I'm going to scribble that out. I'm going to get x equals 7, and I'm going to get x equals 3. Now, I put the equal sign in. Again, these aren't my final answers. These are going to lead me to my final answers. All right? So what I'm going to do is I'm going to make a number line, and I'm going to put those critical values that I just found on the number line. Okay, now I'm going to go back to not necessarily the original, but the part that I set equal to 0. Okay, in here it says we want all the x values that are going to be less than or equal to 0. Okay, now remember back to when we did absolute value inequalities. If I had something that was less than, all right, what that meant is typically I would shade between those two values. All right, and if it was greater than or equal to, I would shade outside of the 3 and the 7. So you'd have lines going in different directions that would represent all your solutions. Now we have to do with this is we have to check. All right, so what I'm going to do is I'm going to take this first interval over here, anything to the left of 3 or less than 3. I'm going to pick a number. So I'm just going to pick like 0 because 0 happens to be on the interval. And I'm going to fill it in to the boxed equation I have up here. So when I fill in 0, I get 0 squared minus 10 times 0 plus 21. All right, well that's going to be 21 is less than or equal to 0. Now is 21 less than or equal to 0? No. So that means that I'm not going to have solution points on that interval. So now I go to the middle part here. I'm going to pick a number in there. So I'm going to pick 4 this time. So 4 squared minus 10 times 4 plus 21 is less than or equal to 0. Okay, and so I just picked, and you can pick any random value off those intervals. I picked 4 because it's probably somewhat easy to work with. So 16 minus 40 plus 21 is supposed to be less than or equal to 0. So 16 minus 40 is going to give us 24, negative 24, plus 21 is going to give me negative 3. So negative 3 is less than or equal to 0. Now that makes sense. So what that means is anything in between 3 and 7, if I were to fill it in to the boxed equation up here, it would make it work. All right, now we talked about from the beginning, because it was less than or equal to, that it should work out that I would shade in between those two x values. But I'm going to check out here greater than 7 just to make sure that I don't have something on that interval will work too. So I'm going to pick 10 this time around. So 10 squared minus 10 times 10 plus 21 is supposed to be less than or equal to 0. All right, so 10 squared is 100 minus 100, so it would be 0 plus 21. So 21 is less than or equal to 0 when I use 10. Now, again, that doesn't make any sense. So that means I won't have any x values that are solutions on that interval either. Okay, now last thing. We have to go back and we have to look at that original sign again. Less than or equal to. Because there's an equal to part with it, that means my circles down here would be closed in. And what that means for us is that 3 and 7 would actually satisfy this equation right here. All right, what would happen is you'd probably get 0 is less than or equal to 0 if you filled both of those in. All right, which in this case, because of the equal to part, is okay. All right, so your number line basically shows us our solutions. Now the last thing would be, how do we write that? Well, there's a couple different ways you can write that. Okay, one would be just to say 3 is less than or equal to x, which is less than or equal to 7. Or basically, 3 and 7 are the outside boundaries for your solutions. All right, or x could be anything in between them. Now the other thing, if you think back to when we used absolute values and compound inequalities, we could say x is greater than or equal to 3 and x is less than or equal to 7. This would also represent the solutions that make this work. And remember, with an and, what that means is it has to satisfy both of them. Not only does it have to be greater than or equal to 3, but it has to be less than or equal to 7 to make that work. Okay, so there's a little bit of work involved with these. All right, but if you pay attention and just kind of slow things down in your head a little bit, it's not really that difficult. Okay, now I want you to try one on your own here, see if you get the general idea what's going on, then come back and we'll work it out together. All right, so first thing I'm going to do again is I want this to be set equal to 0. So I'm going to actually subtract that 2 over, so I'm going to get 8. It's going to be greater than or equal to 0. Okay, now again, this is going to be the equation, or the inequality I should say, that we refer back to at the end when we fill in points. All right, but I'm going to factor this. And I'm going to get x minus 4, x minus 2, and like we said before, for right now I'm just going to set it equal to 0, okay, to find those critical values. So here, if we were to set each of these equal to 0, we get x equals 4 and x equals 2. All right, those are my critical values. Again, they are not my solutions. All right, so I'm going to take my number line, and I'm going to put 2 on here, and I'm going to put 4 on here. Now, going back to this original sign here, it's greater than or equal to. Okay, what that means for us before is the equal to means we should probably have closed circles on these particular values. All right, on our critical values, because we can equal those. More than likely, you fill those in, you're going to get 0 equals 0, or 0 is greater than or equal to 0 for both of them. All right, now greater than typically means an or compound inequality. All right, which means we usually shade outside of those values. Now, we need to actually check to make sure that is correct. You shouldn't just assume, because there are a few times when it doesn't necessarily shade the way that you think it's going to shade. All right, so I'm going to pick something less than 2, so I'm going to pick 0. So if I fill 0 in, oh, excuse me, we're using the boxed equation, that should be an 8 there, is greater than or equal to 0. All right, now technically you could use this one too, but it's easier if you have something where you have 0 on the one side. Okay, well, all of this is going to cancel to 0, so I'm going to have 8 is greater than or equal to 0. Well, that makes sense, and we thought it would, so I'm going to shade on the left side of that 2. Now, the middle one here, okay, this one probably shouldn't work, but we're going to check anyway, so we're going to fill 3 in. 3 squared minus 6 times 3 plus 8 is greater than or equal to 0. All right, so 9 minus 18 plus 8 is greater than or equal to 0. Okay, well, 9 minus 18 is negative 9, plus 8 is negative 1, greater than or equal to 0. Well, that is not correct, so we're not going to shade between the 2 and the 4. So the last thing would be I have to check to the right of the 4, greater than 4. So I'm going to take 5. So 5 squared minus 6 times 5 plus 8 greater than or equal to 0. So 25 minus 30 plus 8 should be greater than or equal to 0. Well, 25 minus 30 gives us negative 5 plus 8 is going to be plus 3. is greater than or equal to 0. Well, that makes sense. So we would shade on this side of the 4 also. So anything in the shaded area as far as an x value goes would make this inequality true. Okay, so now how to write that? Well, remember, this is going to be an OR because we shaded on the outside. So x can be less than or equal to 2, or x can be greater than or equal to 4. All right? So that would be the compound inequality that satisfies this. Now remember, if it's compound with an OR, that means it really only has to be true for one of the two parts, okay, in order to actually have the solution. Now think about this in terms of the graph again, like we talked about before. Okay, if we have 4 and 2 as my critical values, we probably have something that looks like that. Okay, now we're looking for the parts of the graph that are greater than or equal to 0, or basically, where's my graph greater than or equal to the x-axis? Well, if you look at it, anything to the left of the 2, you can see how my graph is above the x-axis. Okay, well, that satisfies this part here. So any x value I would put in that's less than 2, my graph is above the x-axis. On the other hand, anything greater than 4, as we move this way, you'll notice how my graph is above the x-axis. Okay, so if we were to fill in 5, 6, 7, 8, the resulting y value would be above the x-axis. So that just explains what we're looking for. Okay, when we set it equal to 0, essentially we're looking for the portions of the graph that are either greater than or less than 0, or above or below the x-axis. All right, this is just a restatement of what we had on the first example when I said there's two different ways you can write a compound inequality that involves an AND. All right, you can write it with showing the x between them, or you can actually use the AND down here. Either one of them is correct, and either one of them represents the correct range of x values. Now, last thing, and this is kind of the meat and potatoes of the assignment, so to speak, where we start taking and looking at real-world application problems and stuff like that. Okay, so we have a business model here where the equation in the middle, or the function in the middle, is supposed to represent profit. Okay, now just remember, we've basically been doing all this inequality stuff, so we're going to do the same thing for this problem. Okay, basically the profit model tells us whether we're going to make money or not make money, and in this case it says the trip will be rescheduled if the profit is less than $7,500. All right, so if our model happens to yield something that is less than, actually it wouldn't even be equal to, just less than $7,500, the trip has to be rescheduled. Okay, so how many people must have signed up if the trip is to be rescheduled? All right, so in other words, if the x values on this side yield something that is less than $7,500, all right, that means the trip is going to have to be rescheduled. Okay, or in other words, if we don't make a profit of $7,500, all right, it means that we have to reschedule the trip. So I'm going to move to the next slide here, which is empty, just so I have a little bit better idea of what's going on here. So I'm going to restate basically what I just wrote on the previous slide. And as we said, less than $7,500. So let me just click back real quick to make sure that we got the right signs on everything. Negative 25x squared plus 250, or excuse me, 1250 minus 500. Okay, so what we're going to do here is we need to go ahead and set this equal to 0 just like we did before. All right, so if I set this equal to 0, I'm going to get 12,500 in here. All right, and less than or equal to 0, or excuse me, less than 0. Okay, now we would go about doing this the same way we did before. All right, we want to try to factor. Well, the problem with this, if we try to factor, is the simple fact that the numbers in here really don't work out well to factor, all right, to find those critical values. So what we're probably going to want to do is we're probably going to want to use the quadratic formula. Now, don't get freaked out here because the numbers are a little bit larger than they have been before. Okay, so we're just going to go ahead and fill all this stuff into the quadratic formula. I could factor out a negative 25, but it's not really going to help us a whole lot. So we're just going to go ahead and stick with what we have here. All right, so the quadratic formula will still give us the numbers that we're looking for here. Okay, or my critical values. So we need a calculator here a little bit because these numbers are going to get a little bit big. Okay, so what we're looking at is b squared is going to be a big number, 562500, minus, so let me check, 1562500 minus 4 times a, which is negative 25, times c, which is negative 12,500. Okay, and that's all going to be over 2 times a, which is basically going to be negative 50. All right, now we got a little work to do here because our numbers are kind of big in here. Negative 4. All right, so essentially we have 1562500 minus 1250000. Okay, so give me a second here. 1562500 minus 1250000. All right, so negative 1250 plus or minus square root of, I'm going to get 3120, something like that, 312,500 over negative 50. All right, now because this is a story problem type thing we got going on here, all right, I'm not really going to worry about trying to break down that square root. If I tried to take the second or the square root of 312,500, I'm going to get a decimal, okay? And basically that decimal is really, really close to 559. It's actually 559.01. All right, so I'm just going to think about it as 559. All right, because it's a story problem, it's okay to get decimals in this case because we're not going to get whole numbers. In this case, we're just going to say 559 because it's close enough. So what I need to do is I need to figure out my two solutions. So negative 1250 plus 559 and divide that by negative 25. And we're going to get something like 27.64. All right, now on the other hand, negative 1250 minus 559 divided by negative 25 is going to be 72.36. Okay, so those in this case are going to be my two critical values. Okay, so I'm going to go ahead and I'll kind of number line those up over here. They're not the easiest to work with. All right, but we have 27.64 and we have 72.36. Okay, now what we'd want to do is we want to check to see what's going on. Now in this case here, it says we're less than. Okay, we're looking for the points where we would be less than this whole thing right here. Now, the thing to keep in mind also is this is a parabola that actually opens down. All right, so if we think about something like that, all right, less than would be the parts that are below the x-axis, which if you're talking about revenues, all right, we want the output to be positive. All right, so we're really only looking at the parts where the values are above the x-axis. So what I'm going to do first is I'm going to go left of 27.64, and I'm just going to pick 0. So if I fill 0 in to this whole part right here, okay, Basically, these first two would end up being 0. So I'm going to have negative 12,500 is less than 0. Well, that makes sense. All right. Now, I would shade on this side of it. Now, something to keep in mind is because we're just less than, all right, I would have to put open circles on these particular values right there. So basically, what happens is if we have anywhere less than like 27 people that sign up, we're not going to have enough profit. All right. Now, what we should do is more than likely in the middle there, okay, because it's less than, in this case, and everything is upside down, and you look at our graph up here in the corner, you can see that our less than points are probably going to be outside of those values. All right, now what I probably should do is I should probably draw a little bit better graph here, so you can get a better idea of what's going on here. So if I were to draw a parabola in here, now you have to think about this probably isn't drawn to scale that well, but if you say this in here is right around 27 and this in here is right around 72 as far as right here, okay, we're looking for the parts where the graph is actually less than 0 or it's below the x-axis. All right, now I'm looking at the graph or trying to get this general idea because it's probably easier than filling in other values. A 0 worked great because it's easy to work with. But instead of filling in other values, I'm going to take a look at my hypothetical graph a little bit up there. If we'd be looking for the points where it's less than 0, we'd probably be looking to the left of 27, like we already talked about. That's why it's shaded on the bottom. And then probably to the right of 72, anything greater than 72. Now, basically, you could kind of leave that as your answer. You know, if you wanted to go x is going to be less than 27.64 or x is going to be greater than 72.36, you could do that. But let's think about this for a second. We're trying to figure out what's the minimum number of people that would have to have signed up in order for this trip not to happen. So basically, anything less than 27 people, we're going to lose money on the trip, okay? Because if you look in here, the graph is below the 0 line or below the x-axis. Now, on the other hand, and this really doesn't make a whole lot of sense, but if you were to get more than 72 people to sign up, you would actually start losing money, all right? Or the profit would start going downhill. Now, in this case, it only asks for what's the minimum, so we would only really have to say less than 27.64, or basically less than, you know, something around there. But you could also include in your answer, if you wanted to, that if we got anything greater than 72, if we allowed more than 72 people to sign up for this trip, the company would actually be losing money on that as well. All right, so something to keep in mind as we go forward here a little bit. All right, now, you're not going to have a lot of those story problems to do, a few of them here and there. For the most part, you're going to have to graph a little bit, and then you're going to have to use the whole critical value thing, shading the number line thing to figure out x values that satisfy what it is that equation happens to be asking. Okay, so if you have any questions, just make sure that you ask. Otherwise, that is all that I have for you right now. So again, make sure you get a head start on your homework and stuff before you come to class.